Hello, welcome to Anselm Griffin's second part of the tutorial on the WaterShed algorithm. We're looking at part A here first. In part A we're going to be looking at a black and white image. So, the first part, if you remember, we looked at BW distance, so I won't go into that. So we've read in the image, which is a JPEG, we've converted the grayscale, and then we've converted the image to black and white. And that's the black and white image here. And we can see here that there's a number of holes here and here, so what we want to do is fill it in. So the command that we used is imfill, and we fill that in here. And then to get this to work, we had to take the complement of the image, and there's the complement of the image there. And just slight criticism here, there's a couple of extra flecks, and I should have got rid of them, and I would have got rid of them with IM road, and probably I would have IM deleted just to get back to where I was, but I didn't. I left it the way it was. So what we want to do is get the WaterShed, just say if we go there, what's the line that would break that catchment area just there. So what we did next was, did I miss a line there? No, that's okay, we've displayed all of that, and AAC is the complement. AAC is this image here. So what we did was here, we got BW distance and we displayed that image. We had to do a little bit of messing about here. We had to convert it to uint8 and then do IM adjust. So that's BW distance. Okay. Sorry about that. We carry on. So positive integers now correspond to catchment basins, and zero values indicate ridge pixels. So go on. We get the WaterShed here, and we have the WaterShed here. This is the black lines are ridge lines here, and then here I just inverted it later on just to see, just did it make any difference, but I think it's still the same. So that's the WaterShed for the black and white. Now we do part B for the grayscale. Scroll up here. As before, we clear all the variables, clear the screen, and we close all figures. We read in the original image, and to get this to work I have to convert it to double. Remember, it's uint8 if you read it in. And to get this to work, we did a Sobel filter, which is an edge detector, and we executed the edge detector there. We then carried out the WaterShed of this image here, and that's what it looks like there. Okay, and you can see already, without going any further, this is not great because it's way over segmented the thing, but we have to deal with these problems. So just come back here, there it is, and then we're going to, on these lines here, we're going to get the ridge lines. So there's the ridge lines there. Now, can we improve this awful mess? Well, we can improve it. It mightn't be that great, but we can improve it. So what we did here was we took the original image and we smoothed it, and we smoothed it by an opening followed by a closing. Now you could do an averaging filter as well. There's the smoothed image. As before, we ran the WaterShed and we calculated and we showed the ridge lines on the original. So just get you a look at that. You can pause it on YouTube. There's the ridge lines. It's a bit of an improvement. There's less of them. And there's the ridge lines imposed on the original image. So before I finish up, I said I wonder if I improved the not improved, I wonder if I made the smoothing bigger, what would it look like? So how did I make the smoothing bigger? Instead of a 3x3, I went for a 5x5. There's the 5x5, possibly over smoothed, but I just wanted to see what would happen. As before, I got the WaterShed and I displayed the ridge lines on the original image. There's the ridge lines, and there's the ridge lines imposed on the original image. Now it's still way over segmented, but at least it's better than the original when we didn't smooth it at all. Okay, thanks very much for listening.